Good afternoon, everyone. And today, I'm honored to tell you guys that we have teachers visiting our class. Let's clap to welcome them. Alright, so before we start today's lesson, I'm going to take a few minutes to review our homework on uploaded. Look at the screen, and I'm so glad to see that all of you have done your homework. And I want to give the special congratulations to DUNG, to Cương for getting the highest scores. And what I also noticed that there are a few people still got quite low score. I'm considering to give you some more exercise. And I have written some feedback for each of you, and I want you to make sure that you're gonna read them carefully and make corrections to your solutions. But in overall, I'm happy to see that you are all improving. Keep it up. And now, in the previous lesson, we have learned about geometric progression, and today we're gonna dive deeper into it by reviewing formulas and doing some practice. And especially, we are going to explore some real-life applications, real-life problems related to it. So let's get started. Just take out your notebook, take out your calculator, take out your rough paper, and prepare for something. Please write down the title of lesson today. And because the name is quite long, so I'm gonna call it GP for short. So whenever you hear me saying GP, it means that geometric progression. You'll get it? Alright, thank you. And to start, we're gonna play a mini game called Mystery Boxes. It's gonna be a huge fun, so get yourself ready. Alright, because the game is quite familiar to you guys, so I'm not going to explain it in details, but you can refresh your memory by looking at the screen. Here are the rules. Alright? Just want to remind you that in each box, the point can be positive or negative. And one more thing before we start, that I have prepared some interesting prize, interesting gift for the winner today, and it is an exceptional. It's real. Alright, I'm gonna need to split our class into 4 groups. Group 1, Group 2, Group 3, and Group 4. Are you ready? Yeah. Okay, get your calculator. You're gonna need that a lot. Let's start with Group 1. Who is your spokesperson?
I will choose number 3.
Alright, number 3, very fast. He chose number 3. And here is the problem behind number 3. You have 10 seconds to solve it. And I want all the other group, you need to work on it simultaneously with group 1. Everybody, I'm going to check your calculator. Alright, time is over now.
The answer is 74.
74 what?
Percent.
Percent. Alright, let's see. 74. That's correct answer. Oh, you have not done that. You have the mystery box now. You want to keep it or you want to give it to another group? Keep the box. Yes, this is the very first one. So you definitely keep it. Wow! Congratulations. Really a good start. Okay, next group, group 2. Which number do you want to choose for your group? Great. Number 10. Alright. You have 10 seconds with your group. Let's work in group, please.
Cấp số nhân.
Now group 2, I want to hear your result. 108 million people. That's the predictable the population of Vietnam in 2020. That's the correct answer. And you guys, you can see that this is short explanation. Alright? Now you want to keep the box. I'll give it. Give it? Give to which group? Group 1? Wow.
Trừ điểm đi là phải cộng thêm được.
That's the good decision. Alright. Now group 3. Everything just begin. Number 9. Alright, you have 10 seconds. It's up now. One hundred and two millimeter. Okay. Awesome. All right, that's correct answer. I'm sorry for. Yeah, and that's the correct answer. Now, you need to choose to keep or give the box. Keep the box for yourself. Alright? Okay, I will open it right now. Great job. And now group 4.
I would want to choose number 8.
Number 8. You have 10 seconds.
I would have the answer. The answer is 22.
22?
Yeah.
Alright, 22. Let's see. It's an early answer. 22 is the correct answer. Seems to be a problem, right? Now, you want to keep it or leave it?
I want to keep it. Keep it? Yes.
Okay. Okay, congratulations. Alright, now it's your turn, group 1. Group 1. Number 6. Alright, you have 10 seconds. What's your answer?
Answer is
2. See? Alright, the answer is 2. That's the correct answer. You want to keep it or give it to other group? Remember, we have only one winner. Group 3. Alright. Oh, sorry. -4. Alright. Group 2 is your turn. Number 1. Okay. You have 10 seconds. You need to find your turn. What's your answer? 12 term. Alright, let's see. 12 terms. Alright, that's the correct answer. And you want to keep or keep the box? Keep your scholarship. Wow. Oh, so sorry. And then because the limit of time, so we're gonna stop here. That's right, we still have some questions, alright? So I will need to do the calculation to see who is the winner today. Can everybody help me? Alright, so group 1, you have -1. Group 2, 8 and 3 points, 2 points. And the winner is clearly group 2. Congratulations. Alright, so for the prize, you're gonna receive it after all of this, alright? And now, through the game, you guys have a chance, an opportunity to review formulas and to test yourself with typical problems. And now I want to hear from someone. You guys, can anyone tell me, remind me and the whole class for the which formulas we most use to solve the problem in the game? I want to hear the most used formulas that we use to solve the problems in the game. For the first one, who? Okay, now. The first one is recursive recursive formula. All right. And recursive formula is also the first formula in the lesson. Can you read the formula for me? U sub n times q. What is q? Common ratio. Okay, thank you. And I want more. Anyone? Okay, fine. General term. Formula. All right. Can you read that? U sub n to the power n, with n belongs to, -1, with n belongs to the set of the natural numbers, non-zero natural numbers. Thank you. The last one, I want to hear one more. Oh, thank you.
Teacher, what's the sum of the first n terms?
Can you read that? U sub 1. Okay. All right, thank you. Thank you. Sit down, please. Okay, anyone? Can you see? Are they all correct? All right. Those are the key formulas of the lesson. And for those of you who still find yourself stuck somewhere in the game, you might need to review all the key formulas. And for the complete formula table, you can find in the almanac on the page 28. All right, and make sure to remember them firmly. Okay. And now, we're going to move on to a very exciting part of this lesson today. You know that GP is not something that just belongs to math. We can find it everywhere, it appears everywhere. From the micro world of bacteria to the macro world of universe, the planets. Okay, so in the last lesson, I have assigned some projects related to GP to the groups. So now we're gonna welcome group 1 with their presentation about project 1, which was to create a compound interest. Let's give them a big hand.
Welcome everyone. Today we're group 1 and we're going to tell you guys the secret of compound interest.
It's a very interesting topic because it shows how math can make your money grow using geometric progressions.
you want to know the secret of the world billionaire like Warren Buffett?
Today we will tell you it's not about luck, it's about something called compound interest, which looks like a geometric progression.
Let's see how it works.
So, what is compound interest? You know, your money earns interest every year, and the next year, the interest you earn also generates in all interest.
So your money doesn't just add, it's multiplied. And that's why compound interest go much more faster than simple one. One principle that can demonstrate compound interest perfectly is the snowball effect.
Have you ever heard people say money can grow like a snowball? What do they mean by that? Thành?
They mean that if you save or invest money and make it earn compound interest, it can grow faster and faster over time.
Exactly, thank you.
Okay, now imagine a snowball rolling down the hill. At first, it's still small and pick up snow slowly, but over time, the bigger it gets, the more snow it can gather. So it grows faster and faster over time until it becomes enormous.
That's exactly how compound interest works. The more money you have, the faster it grows. But the important thing is, time impatience can turn small things into a big result.
And here's the formula of compound interest. A equals P times 1 plus R in bracket to the power of n. Can anyone tell me what these notations stand for? Yes, thank you.
So can you explain that? What does P stand for? Hein, please. Yes, it's his principle starting money. Thank you.
And what about R? You.
R is interest rate.
Thank you.
What about N? Can anyone explain to me? Nan, please.
Accidental and rubber errors.
Okay, thank you guys. It's all exactly.
So each time we multiply by 1 plus R in brackets, the entire amount grows again. This multiplication is a geometric progression where each term is larger than the last, like constant ratio. As Warren Buffett once says, my wealth came from compound interest and time.
Okay, now I give you guys a real example. You guys will invest 1 billion VND with 50% annual growth for 10 years. So the question is, how much money will you have at the end of the period?
Okay guys, we just simply use the compound interest formula. And here we have A equal 1 billion times 1 times 15 in brackets to the power of 10. And the answer is about 4.05 billion VND, more than 4 times the original amount.
As you can see, with compound interest, Germany grows much more faster, while with simple interest, it's only over half of it. Okay, now who wants to become a billionaire someday? Now, imagine this, in a dream, you have $1 million and you dream of becoming a billionaire someday. Let's say each year you earn 20% profit. So, how many years will it take for you guys to become a billionaire?
We will give you guys 2 minutes to get us the answer.
Grab a notebook and calculator and give us the answer.
Interesting challenge. So I want everybody to join this. After you have done, just show us your calculator.
Okay, thumbs up. Thank you. Now, can someone give me the answer for this question? We.
My answer is 13 years.
can you explain to me?
The definition, we substitute P with the other dog. And backwards.
Thank you.
So let's see the answer. And yes, as he said, is about 13 years, an impressive figure. So let's dream big, and you will become a billionaire one day. And now, I want to introduce you guys our wonderful members who will give instructions about our group helpful tool. Let's give a big hand to Chen. Now, to make our topic more practical, we have created an Excel tool that can calculate both simple interest and compound interest with a very easy use. Users only need to enter 3 pieces of information: the initial amount, the interest rate, and the number of periods. After entering these values, our sheet will generate 2 columns, one showing the money grows with simple interest and another showing how it grows with compound interest. So, our tool allows users to compare the difference between the 2 types of interest directly through the numbers they entered. And we believe that our tool can help students see how compound interest grows faster than simple interest, not only as a formula, but also as a real visual experience. And it is also a very easy way to understand why compound interest is often called the power of growth.
Thank you for your wonderful speech. We'll send this tool in our class group after this lesson for you guys to try it yourself. So, anyone has questions?
I'm really interested in your tool. And Lee, can you guide me how to use the tool? Alright. So, Lynn, can you tell me which criteria do I need to enter to your tool to get it to start calculating?
You can just enter the initial principal and the interest rate.
Oh, how easy. I just need to. Does anyone want to try it together?
Yes.
Okay, done.
I want the initial amount. I want 18 million.
18 million? You have that money? 18 million only. Alright. And then, what about the interest rate?
I want 36.
36? Oh, 36. Kind of pretty people. Alright. And you guys can see that everything is calculated automatically. Can you see that? And in this column, it is compound interest. And this is for simple interest. And it is very, very easy for everyone to see that the more periods, the bigger the differences. Alright? Wow, really amazing tool. Thank you, Lynn. Once again, thank you, Group 1, for your really clear presentation, a really good voice. I really like your presentation style. And however, I just want to add some more ideas for Group 1. In the case you want to upgrade your project into the next level, to the next version, okay? So everybody, we have learned that we have 2 types of growth. The The first one would look like this. And we call this linear growth. And the second one looks like this. And we call this exponential growth. Exponential. Exponential growth. And you need to remember that exponential growth and compound interest is not something just belong to money area or finance. It also appears everywhere in real life. For example, bacterial growth, exponential. The growth, the population of a country, exponential. And even the growth of your knowledge is exponential too. Can anyone tell me why can't we say that the growth of knowledge is exponential? Oh, Ozia.
Because now we know faster, we learn new things.
Oh, thank you so much. I really like your sentence. The more we know, the faster we learn new things. And that's why we should keep growing your knowledge. Alright? And the last example I want to give you today is the growth of technology. That is really interesting. Do you guys, can anyone here tell me what is the highest storage capacity of the latest iPhone at the moment? Okay, huh?
It's about 2 terabytes.
2 terabyte? Oh, 2 terabyte. 2 terabytes. So can you help me to convert this into gigabyte? Gigabyte? 1048 gigabyte. Thank you. And you may not know that the very first version of iPhone had only 4 gigabytes storage. Only 4 gigabytes. It is around 15 years. It's only around 15 years ago. The very first iPhone just started with 4 gigabytes. And after that, around 1 year, it rises to 8 gigabytes. And after that, 16, after that, 32, and then 64, and just by connecting the dots, we can see it clearly exponential. All right. So once again, thank you, Group 1, for your hard work. And by the way, I really like HÍNH's voice, and I hope someday you can do something that related, that can use your voice useful. And you know that GP is not something that just belongs to math. So it is also widely accepted by nature. And now we're going to welcome Group 2. Will come here with their presentation about the beauty of nature through geometric patterns. Welcome, Group 1. Let's rock it.
welcome to our group 2. My name is Đựng
And my name is MỳNH.
Today we will talk about the nature of beauty in the geometric progressions.
Nature speaks in numbers. From the tiny leaf to the grandest galaxies, pattern repeats, growing, multiplying, and expanding. Behind this silent harmony lies a mathematical rhythms, geometric progressions. Today, I will show you the incredible performance of nature with the theme Nature's Beauty of Geometric Progressions. Let's explore how this beautiful pattern shape the world around us.
And let's begin with the word of plants. Every fern, every leaf follows a pattern of repeated growth. One branch becomes 2, and 2 becomes 4. That is the geometric progressions in motion. As you can see, even mushroom grow in this way. One spore creates many, and those many creates more. Watch a seed grow into a plant. Each new stem divides again and again. A forest begins with 1 tree, then 2, then hundreds, growing faster and faster like a geometric sequence. And look at the sunflower. The spirals repeat again and again. And the smaller part look like the whole. That is the beauty of the fractal growth in nature.
Oh, I remember you have questions for our classmates. Can you do it?
Oh, sorry, I forgot. And we have questions for my clever classmates. A tree starts with 1 branch and doubles its branch in each week. So how many branches will it have after 5 weeks? And we have 5 seconds for my friends. Time's up, so do any have questions? Any answer? Okay, Minh, please. Okay, correctly. Give a big hand to Minh.
Not only in the world of plants, geometric patterns also appear in the world of animals. As you can see, the spiral of natural cells grow in a constant ratios, each being chamber larger than the last. Next one, on beehive, the hexagonal cells repeat in the perfect order, creating efficiencies through repetitions. The last one is a coral reefs branch like trees. It also repeat in the perfect order rules. In this part, I have a very interesting questions for you guys. In a honeybee colony, if we trace back a male bee's family trees, the ancestor following which famous rules? I will have you guys 5 seconds to answer this question.
Remember, that's very famous.
Okay, time's up. Meantime, please. Spot on. You perfect.
And finally, the natural phenomena. Beyond living creatures, the geometric progressions also shape the natural events too. And look at the snowflakes forms to repetition. Each arm divides again and again, creating a perfect symmetry. A lightning bolt branches the same way. Each strike splits into many smaller parts. And both lightning and snowflakes follow the same law, growth by multiplication. And in this part, I have a question for my friends. If we drop a bouncing ball and and it lost half of its head in each mouth. So how many heads will it remain in the fourth mouth? We will have 5 seconds for these questions. So time's up. Who has the answer? Lâm Hà, please. So the answer is 4. Correctly, Lâm Hà, give a big hand.
In conclusion, from the microscopic scale of DNA and cell divisions to the vast galaxy of the universe, the same rules appear. Nature grows not just multiplications, but additions.
And that is the language of the geometric progressions, which connects life, matter, and spaces. Math is not only numbers, it's the poetry of how our world grows. And thanks for listening. We really appreciate your time and attention.
After our presentations, do you guys have any questions and contributions? Link, please. Thanks for the questions. So we noticed the similarity between these two, math and nature. So we chose this topic because, by the way, it's very similar with the geometric progressions. So we chose this topic.
Thank you.
Okay. Thank you, Group 2, for your great visuals and for your confident presentations, CHIAO. And I just want to give you a minor operation for your question. One of your questions that is Fibonacci is not a geometric sequence. I think that Group 2 just want to make it more attractive for everyone, but keep in mind that Fibonacci is not a geometric progression. Alright, you get it? Alright. And in the end of our lesson today, I just want to give you some homework. You remember that we have reached the end of the lesson 3. So today the homework is you need to research all the AI tool or everything you can use. Just make a mind map, okay? Or any kind of conclusion to conclude all the key ideas, key concepts of the geometric progression lesson. Is that okay for you?
Yes.
And I want to introduce to you a very amazing tool that can help you to do that. We have that is Notebook LM. This is the address notebooklm.google.com. Yeah, this is an amazing tool for you because you just need to add some file, just like ebook or just textbook. Okay, just write with your textbook. All right, and then after adding the textbook, you can require it to do some actions like create a mind map or create video, overview video, overview audio. It is really easy and very useful for you to review the whole lesson. Okay, and at the beginning of this lesson, I have tried and I got a video like this. Actually, I and Cương, we have tried this, and let's see what we have.
Is all about a simple but incredibly powerful idea. Welcome to The Explainer. Today we're going to unlock a really powerful mathematical idea that, believe it or not, shapes our world in some pretty surprising ways. We are talking about the hidden power of geometric growth. So let's start with a question. What could bacteria, your savings account, and a viral video possibly have in common? I know, it sounds like the start of a bad joke, but the answer is actually a secret mathematical pattern that they all share. And that pattern is all about a simple but incredibly powerful idea, multiplication. It's called a geometric progression, and it is absolutely everywhere. For instance, our source material for this brings up E. coli bacteria. In the right environment, its population can literally double every 20 minutes. So 1 becomes 2, 2 becomes 4, 4 becomes 8. You can see how fast this thing just explodes.
Yeah, you can see it's really, really amazing, right? It even can take a capture of your textbook and explain more details by adding more diagrams or more graphics. You know that? And it is very easy to understand. So let's try it at home right today. Okay? You get the homework now? Okay. So it's today is the lesson with full effort and hard working. I want to say thank you to all the class, to all the teachers, all the visitors for coming here and for your concentration. Thank you so much. Let's stand up for stand up.
Chúc mừng các thầy cô có tiết dạy buổi sáng đã thành công ở tiết 1. Trân trọng kính mời các đồng chí lãnh đạo, các thầy các cô di chuyển những cảnh của dãy nhà A, tức là giáp với dãy nhà D. Thì nhà trường có bố trí một chút bánh kẹo và nước mời các thầy cô. Các thầy cô đang dự môn tiếng Anh ở phòng số 8, mời các thầy cô di chuyển xuống sảnh của